didn't work out like it does in the movies. But I got to thinking, and that happened to me all the time when I was little. Well, I was on a bike, so it's a little more understandable. But that's besides the point, okay? Okay. But then, I guess it was just because my tires were low, so it made me crash, but then I should have just aired them up, but you know, young and dumb.
I'm sure that many of your tires have gotten low and you're busy bicycling along.
So, how do you air those tires up? With a bicycle pump, of course! To understand how a bicycle pump, well, pumps, we need to start with a basic lab. Use my hand. Okay. So, make sure there's no air that can get in or out of the syringe. As we press down, the marshmallow gets smaller. And as we pull up, it gets larger. Show it again. Down, it gets smaller. Up, it gets larger. First of all, this is a physical change because the marshmallow is not changing any of its properties and it can be turned back to its original form. Okay, so you may be wondering why the marshmallow changes shape, which that's a very typical question. And it's because of PTV, pressure, temperature, and volume. And pressure and volume are inversely proportional, which means that they do the opposite of each other. So temperature in our case is going to remain constant because we're not changing the temperature in the syringe. There's not a magical heater in there or anything. And so if the pressure is increased, the volume is decreased. And in the other way, if the pressure is decreased, the volume is increased. These are inversely proportional, is what it's called, because they do the opposite of each other. To understand this further, we need to take a look at a particle diagram. The diagram on the left shows what it was before we pushed down on the syringe. The air molecules have more space so that particles are farther apart. On the right, after we pressed down on the syringe, the air molecules did not disappear, they just got closer together and compressed. So that's why the marshmallow changes its volume. But how can it change its volume? This is because it's an amorphous. And that means that it does not have a shape. The word amorphous actually means without shape. Their atoms and molecules are randomly arranged, giving the marshmallow the ability to change its shape that easily. However, it does not mean soft or flexible. No. Amorphous structures are classified this way solemnly on the fact that their atomic structure is disordered. Okay, on to the bicycle pump. There are many air molecules in this cylinder. And as we press down on the handle, the volume is decreasing, making the pressure increase. Because remember, volume and pressure are inversely proportional. And as the pressure increases, it forces the air to go out this tube and into your bicycle wheel. Oh! 577, 578. Another example is a road trip to Pikes Peak, Colorado. Above sea level here is only about 500 feet, but when you go to Colorado, the elevation above sea level is over 14,000 feet. That's a huge difference. Now the temperature here in Colorado is about the same. So if the temperature is remaining constant, and as we go up in altitude, the pressure is decreasing, then the volume has to increase. So if you have your bag of chips for a snack along the way, and the pressure is decreasing, the volume in this bag of chips is going to increase until there are no spaces left and it is tightly compressed.